Webb Telescope captures shocking sea of galaxy's biggest star nursery. Observatory centered on Sagittarius B2, mammoth atomic cloud found fair a number of hundred light-years from supermassive dark gap at galaxy's center. NASA's James Webb Space Telescope on Thursday disclosed distinctive pictures of stars and infinite tidy inside the Milky Way's busiest stellar nursery. Concurring to NASA, the observatory centered on Sagittarius B2, a mammoth atomic cloud found fair many hundred light-years from the supermassive dark gap at the galaxy's center. The zone is firmly pressed with stars, thick clouds of gas, and complex attractive areas. In spite of the fact that Sagittarius B contains, as it were, approximately 10% of the gas close to the galactic center, it is dependable for creating half of its stars. Much appreciated to Webb's capacity to distinguish infrared light, researchers can peer through the thick clouds in this locale to think about how stars and other structures shape there. One of Webb's mid-infrared instrument pictures captures Sagittarius B2 North, depicted by NASA as one of the foremost molecule-rich locales known. The Milky Way uncovers the gas and tidy there in phenomenal detail, with stars obvious as it were as black-out blue focuses sparkling through the thick clouds. Utilizing the telescope's near-infrared camera, NIRCam, space experts watched colorful stars lighting up the encompassing gas and clean. Analysts arranged to proceed analyzing these stars, measuring their measure and age, to extend understanding of how stars take shape in Sagittarius B2. In spite of the momentous clarity of the new pictures, some secrets stay. NASA explained that parts of Sagittarius B2 that show up dull and empty are in reality stuffed so firmly with gas and clean that not even Webb can penetrate them. Inside these hidden pockets lie the earliest stages of stellar life, protostars still wrapped in their natal cocoons, quietly growing before emerging into the galactic stage. Researchers believe that as Webb continues its mission, it will provide deeper insights into how star nurseries like Sagittarius B2 evolve over time, revealing the fundamental processes that have shaped not just the Milky Way, but galaxies across the universe. With each new image, the James Webb Space Telescope is not merely showing us where stars are born, it's allowing humanity to watch creation itself in progress, unfolding at the very heart of our cosmic home. The James Webb Space Telescope's observations of Sagittarius B2 are not just visually stunning, they are scientifically transformative. For decades, astronomers have known that the galactic center is one of the most turbulent and mysterious regions in the Milky Way. It's home to Sagittarius A*, the galaxy's central supermassive black hole, surrounded by violent storms of magnetic energy and immense radiation. Until now, that environment has made it nearly impossible for scientists to study how stars can form and survive so close to such extreme forces. Webb, with its infrared vision, is rewriting that story. Its instruments are designed specifically to see through cosmic dust that blocks visible light. By observing the universe in infrared wavelengths, Webb can capture light that has traveled for tens of thousands of years through vast, dusty corridors, light that reveals the hidden skeleton of our galaxy. In the case of Sagittarius B2, that means peering into a part of space where new suns are being born every single day. The data collected by Webb offers astronomers clues about the chemical fingerprints inside these dense molecular clouds, identifying elements like carbon, hydrogen, oxygen, and nitrogen, the essential building blocks of life itself. According to NASA scientists, some of Webb's readings show the presence of complex organic molecules, compounds that could eventually form the raw ingredients for planets and even life. These molecules are the same types found in comets,
asteroids, and interstellar clouds throughout the Milky Way, suggesting that the seeds of life may be far more common in the universe than once imagined. Dr. Jennifer Wiseman, a senior astrophysicist with NASA's Goddard Space Flight Center, described the discovery as a glimpse into cosmic evolution itself. We're not just seeing where stars are born, we're watching the environment that gives rise to everything: stars, planets, and the chemistry that makes life possible. It's like watching the universe paint its own masterpiece. The findings also raise profound questions about the timeline of star formation near the galactic center. Astronomers believe that areas like Sagittarius B2 have been forming stars for millions of years, but Webb's images suggest the process may be much more active and dynamic than previously understood. Some clusters appear to contain hundreds of stars in various stages of growth, from newly forming protostars to massive luminous giants that are already shaping their surroundings with intense radiation and stellar winds. What makes Webb's achievement even more remarkable is its technical precision. The telescope, orbiting roughly 1 million miles from Earth, operates at temperatures colder than -220 degrees Celsius. Its sunshield, the size of a tennis court, protects its instruments from solar heat, allowing it to capture faint light from the farthest corners of the cosmos. Even the slightest vibration or error could distort its data. Yet Webb continues to deliver images of unprecedented clarity and depth. As the data pours in, teams of scientists around the world are collaborating to decode what Webb has revealed. The goal is to build a comprehensive 3D model of Sagittarius B2, a digital reconstruction that would allow researchers to virtually fly through the region, mapping where stars, gas, and dust interact on both microscopic and galactic scales. In the long term, NASA hopes that Webb's observations of Sagittarius B2 will help answer one of astronomy's oldest questions: how did our own sun come to be? By studying these distant nurseries, scientists can better understand the conditions that once existed when our solar system was born, some 4.6 billion years ago. The hope is that Webb's findings could illuminate the shared origins of all stars, including the one that sustains life on Earth today. But for now, the world is simply marveling at the beauty of what Webb has shown us. Across NASA's official channels, millions have viewed the new images, many describing them as hauntingly beautiful, glowing clouds of amber and gold, swirling against a dark cosmic backdrop. To the human eye, it looks like art. To astronomers, it's a scientific revolution unfolding in real time. As Webb continues to scan the heavens, its mission is far from over. From newborn stars in our galaxy to the first galaxies that ever formed after the Big Bang, Webb is pulling back the curtain on the universe's deepest secrets, one image at a time. Every time Webb takes a new picture, NASA wrote in its statement, we are reminded that the universe is not a static place. It is alive, changing, and still creating. The discovery at Sagittarius B2 is a powerful reminder of that truth, that even in the heart of chaos, amid clouds of dust and gravity's pull, the universe continues its eternal cycle of destruction and creation. Somewhere, beyond those glowing veils of gas, new stars are being born right now, blazing to life in the darkness, just as our own sun once did billions of years ago.